Yeah. I do this.
Okay, week 9. Anyone noticed, well, I know at least one person noticed that module it is. The module that we just completed on Sunday, everyone has a 0. I think it was 9. Module 9. I don't know why. It tells me that it's syncing the grades, but it's not. I don't know what happened. It's got to be on Alex's end. And then Blackboard puts a 0 because it was due Sunday night. But your grades are on Alex, so I know that's not the problem. So at least we know what they are. If it doesn't update, I can plug them in. But I don't want to put something in and then it goes to update and something else crashes. So it's telling me they're syncing. My guess is they did an update and something didn't work. So right now you may be showing for the module it was due and the hours a 0. I tried updating your hours, like if you got 100% but didn't get 100% of your hours, I put those in on Alex, thinking it might like jumpstart it, but there is a button. But then if I tell it to resync everything. I'm wondering if it's gonna put double of everything. So I don't wanna do that. But if, I'm gonna talk to a couple people and see if they're having the same problem. If not, I will figure it out this week. But as long as your grades are showing on Alex, this is not a problem.
Usually, like, I have like a 0 out of 10 on the time goal, but the module always like updates. I think 7 my blackboard, and it's usually the time goal that's a 0 out of 10.
Yeah, so I didn't, and one person has a grade on the time goal. Everyone else has zeros. I don't know how that happened, but one person got their grade. Which I thought was really strange. We'll figure it out. It's not a big deal. Week 9. On their exam, there is an in-person exam on Friday, the 28th, over chapter 4 through 6. The take home went up Sunday morning. And it's due next Sunday, this coming Sunday, which is the 30th. You go under week 9. Well, this is just for me to open, but put computers, watches, and phones away, nothing on the desk except calculator, pencils, and exam. One empty seat between each person. For Alex, you should have a knowledge check and then catch up module 2. The take home portion of the exam is right here. There's 10 questions if you haven't opened it yet. But it's not timed. You can open it, you can print it. I will make a video just in case certain things don't show up. Sometimes they show up weird, the tables and things. So I'll make a short video showing the pages. That way, if you think something's not showing up, you can check that. That's the same. Review for the exam is up here. It's just, this is kind of, make sure you know these formulas. We'll go over problems. So you want to make sure you know these. Go over the sample problems first or go through these. Okay. I made it this. Rounding. There's some where I just tell you where to round, like when you're finding a probability. That's usually the preference of the person or the teacher. So there's different rules for probabilities, but for a Z-score, anytime you're finding a Z-score, Z-value, it should be around 2 decimal places. Because if you're looking it up on the table, the column has the first decimal place, you go around across to the second. A Z-score has to be around 2 decimal places. Mean, variance, standard deviation, mean of a sample of means, standard deviation of a sample of means. 1 decimal further than the data. Most of our data is whole numbers, so it's usually 1 decimal place. So if your data is all to the 10th, then you round to the 100th. You go 1 decimal place further than the data. On the test, anything else, it will either say or don't round. I don't know that this comes in, oh,
What does it say on the side? I can't see.
okay. Right here. So you round 1 decimal place further than the data. When you're doing like standard deviation divided by the square root of n or something, keep that whole answer till the very end. I know that Alex says go 4 decimal places, but rule of thumb, you should never round until the end. So that's what you want to do for rounding on the in-class and take home. I didn't take the take-home exam yet, so I don't know if we'll need any other types of rounding, but I think this is it. But if so, I'll let you know. The in-person has 10 questions. It took me 10 minutes, so you should have no trouble taking it in 50. I try and stay under 15 minutes. Then that means I shouldn't have anybody left in class. So it should be. Picking 4 marbles from a bag. How can it be made independent? And then how can it be made dependent? So that I know that you know the difference between independent and dependent, which is the second one on here.
It could be made on, like say, you pick a marble out and you put it back in.
Okay, so if we take a marble out and then we put it back in, that would make it independent because I'm not changing the next probability. Yep. So independent, each time the probability of each thing is staying the same. And that means when we pull that marble out, so that we're not changing, we need to put it back in. But then for dependent, one depends on what happened the first time. So dependent, you're not putting it back in and you're changing the probability. So what the paragraph explaining? Any questions on that? So for independent, you're putting the marbles back in every time you pull it out. That way you're not changing the probabilities. Whereas if you keep it out, then it depends on the one before. So the main thing is the independent, you know that you have to put it back in, so it doesn't change probabilities. Dependent, you keep it out and each probability then changes. Any questions on that? To make sure. I am recording this, so you could always go back in case there's something that you missed.
Ten outcomes?
Say that again?
10 outcomes?
No. Somebody gets something else. Remember, each outcome, each event. We toss a coin 5 times.
We multiply how many outcomes 2 times 2 times. Is it 32?
Might be. So there's 32 possible outcomes. Probability at least one is heads. I have you write it as a fraction, a decimal, and a percent. The decimal, let's round 3 places. I'm not sure what it comes out to. It might not need to. And the percent, 1 decimal. Depending on what it comes out to. Yeah. A lot of cases with 1 or more, because it could be the first one, it's a heads, the second one, third, fourth, or fifth, these two, these two, these two, these two, and so on. A lot of possibilities. When there's a lot of possibilities, what's another way we can find it?
Trees. How we took the tree and so it's
I think you were saying 1 minus, yeah, it's complement.
Oh.
So the probability at least 1 head is 1 minus the probability, none are heads. Because there's a lot of cases, and we sure don't want to have to write all 32 of them down. But how many cases are there where none of them are heads? Only one, right? They have to all be tails. So there's only one case. It's a lot easier than trying to find all of those. So if there's only one case, 1 minus 1 out of the 32. (31 out of 32? So now you have to write it as a fraction, a decimal, and a percent, just so I know you know your conversions. So we have 31 32nds. How do we find the decimal? Probably got the decimal first. Hot or cold? 31. Just divide them. Now we're rounding 3 decimal places. 9, 8, 9, 6. And then the 8's gonna go to a 9 because it was 9, 6, 8, 7. So rounding 3 decimal places, that would be a 9. If you have a decimal, how do you get a percent? Multiply by 100. 96 point. Any questions? Probability rules. Counting rules. Your counting rules tell you that you can look at how many there are for each one and then multiply them together to get the total number of outcomes. That's what the counting rules are. Any questions on that? Three of the problems use this type, so there's actually 3 problems in here. 46% of college students and I got that off the internet, so I don't know how true it is. 46% of college students like math. One question says, what is the complement and what does it mean? How do we find it?
1 minus 1 6. And then it means that people.
It's the opposite of what you have. So the complement, and we used it over there on the end, is 1 minus, and it's just the exact opposite, because remember you have to add up to 100%. So 54% college students Do not. It's the rest of the group. Any questions on that? Using the same. There's one for the binomial. Because isn't that binomial? What is binomial? You only have two answers. You either like math or you don't. Using binomial formula. If 35 college students are chosen, what's the probability? So if you want to have a sheet, I mean, you can't do that on the test, but if you want to pull a sheet of paper out just to put your formulas on, probably a good idea. This would be a formula. So with the complement, probably. The formula for the complement. Is just. One minus p. So if our proportion's p, the complement's 1 minus p. Binomial formula, combination, n choose r, e to the r, q to the n.
Can we use our calculators for this one?
Yes. You do not have to remember the formula for combination. You can use your calculator. And my calculator has it. To bring it. But if you borrow one of my calculators, it has it. I'll bring them next time. N is the sample, R is the number chosen. No, N is the number chosen, R is the number successive. Okay. So R is the number of successes, N is the sample size, P is the probability of success, Q is the probability of failure then. You're a binomial, you either succeed or you fail. You either like math or you don't. And Q, to find Q, it's 1 minus P. It's the complement. So in this one, we'll go ahead and do it, and then I'll do it. Depending on your calculator, if you have a TI 83 or 84, it's under math and then go over to probability to get your combination. Some of the other calculators, it has it like right in the middle here, it says probability and you click on it and then it gives you something. Does anyone need a calculator?
Yeah.
My daughter's in the office, she can bring it down.
Well, is it going to find to myself?
Oh, yeah,
Okay.
not on the test, but
Yeah, the test,
test you have to use my calculator or bring one.
I used to have my own, but it's like really old.
So N is our sample size, and this is, oh, I'll write it over here. The 35. R is how many you're choosing to have 20 that like it, so those are your successes. P was the probability of success. 46%. And we found Q. So this is 35 minus 20, which is 15. These two should add up to N. 20 and 15 is 35, we did something wrong. And these two should add up to 1. I said what to round this one to. I went 4 decimal places. Thank you. That way you can make sure you know where everything is. Is there anyone that needs a calculator? Could be, I will calculate just that, but it looks like it's entered correctly. And then you just want to get times and put the other parts in. Anyone else? So there's a button that says probability, PROB right here. And when you hit that, it'll show you all 3, but you have to put, so just for this part. You'll hit the 35. So push 35 and then hit probability and go over to the combination one, the C. Hit enter and it'll put it in there. So 35. And then go over to this and it'll actually put this there. And then put 20 and enter. And it's a very large number. There's a lot of possibilities. So the probability that all 35 of them like math would be 1 out of that number. Once you get this, just hit times and do the rest of it if you're doing them separately. If you want to do it all at once, you probably need parentheses around this and then put the rest. But you could just hit parentheses, oh, no, you have to hit times, okay? Times 0.46, and then you use the caret button for the 20 times 0.54, and then the caret for the 50. And you should get this. Is anyone not getting that value? So you first have to put your first number at the 35, and then probability, and then go over one to this one, and then hit enter. And then you put your 20. Hit enter. And that gives you then the first part of the number. Then you have to multiply by 0.46 times 0.46. Caret, yeah, and then a 20. And then you could do the rest of it with it also from the times 0.54. Is everyone getting the answer? God, ask me now and not on Friday.
I don't know. Okay, so is it only this or is it this?
Okay. This is only this part.
Oh,
Some students were just going to this first. So we want to make sure that.
Oh, and then maybe
This is, which I just, like, if you do this first, then just hit time to that part.
oh, okay. Because I did it all together at first and then I was like, yeah.
I agree. Okay, so first hit the first number, 35, then hit probability, then go with the combination. And then hit the 20. And then I would hit enter first. Then you would just hit times, and then the other one's 0.46, and use the caret for the extra. 20. Point four.
Oh,
Then caret.
only it that can be negative, but now I'm
Okay, so for the first part, it's 35. And then you go to probability. Over to this one. And hit enter. And you type in your 20. So that's the first part. Then you should be able to, go ahead and try. So hit times the 0.46. And then caret for the 20. And then times 0.54 and caret for 15. It's rounding it. Let's see here. Somehow the decimal places is, that's all it is. You're doing it right. Someone changed the decimal places on this one. Let's all look at this. Any questions? Everyone's getting the answer? So that would be a separate problem on it. And then there was one more that uses these, but it's a separate problem also. Find the mean, the variance, and the standard deviation. So one thing you want to put on your formula sheet is make sure you know this. And know what these are. You cannot use the formula sheet during your exam, but you can use it to study. Mean variance and standard deviation. So same problem. When you have a binomial, does anyone remember what the mean is for the binomial?
Yeah, that is.
Variance is n times p times q. And standard deviation is just the square root of that. So there's one problem where it asks you to find the mean, variance, and standard deviation for a binomial. And we'll just use this problem, that way I didn't have to make a bunch of problems. I don't remember what I said over the test, but we'll round 3.
You said how many places was it? You said 4 places still?
3. Now, if you need to find the standard deviation, even if you we're not going to round this because we're going 3, but even if you rounded this, use the whole thing for the square root. So don't, like if they're having you on Alex, round 1 decimal place, and then find this, use the whole decimal. I'm getting 16.1 for the mean. Variance, 8.694. And then the square root of that, 2.948. Now the next one's a 5. If we're going 3 decimal places, this becomes a 9. Any questions on that? So that's half of the test. Oh, that's right, we're 2 hours today. I'm like looking at the clock on. Any questions? Oh, so there's like contingency table. I put a lot of questions on this because I have this on the take home. There's really only one question. On the in-class one. But I figured it was good practice so you understood the take home also. The one on the in-person exam is this question. So we have people who use cell phones, people who don't use cell phones while they're driving, and then the number of speeding violations. Is cell phone user and no violations mutually exclusive? Do we know if they're mutually exclusive? So that they can't happen. Which means the probability of cell phones using cell phone use. And no violations. Needs to be 0. So the and, use cell phones and no violations needs to be 0. Is it 0? Find the probability that you use a cell phone and you have no violation. Use a phone would be this. No violations is this one. So it's not 0. It's 280 out of the 755. Since this probability does not equal 0, they are not mutually exclusive. So you can show this probability and what it is. Since it doesn't equal 0, or if it does equal 0, they are mutually exclusive. But then you'd have to have a 0 in your table. So find their probability, say that it doesn't equal 0, therefore they are not mutually exclusive. They have stuff in common. Any questions on that? We'll find some more probabilities just to make sure you understand. Okay, so that one is on the in class. The take home has a contingency table with a lot more questions on it. So what's the probability if we choose one at random, the driver uses their cell phone? We'll start with these 3. So what's the probability they use their cell phone? Anyone?
305 almost 155.
So if you go across using cell phones, there's 305 people who drive while using their phone out of the 755. Do not need to reduce. You can leave it as a fraction. So it's always the total number divided by how many there were in the survey. How about the probability no violations?
$385 out of the 755.
Does everyone see where the numbers are coming from? So for using phone, there's 305. The second one was no violations, so the total number of no violations over the 755. How about the or?
You will do 305 plus 685 on the 7.
Almost. Notice if we take this and add them, and then we take this and add them, we're adding this in twice. So you have to subtract the probability of both of them. So the formula for an or, unless they're mutually exclusive, probability of A or is the probability of A plus the probability of B, which is what we have here, but then you have to subtract the overlap. Remember, or could also be written this way. So this means or, and this means and. So we have to subtract that overlap, which was 280. Any questions on that? And this line means given. So the probability you use your phone, given you have no violations. And the probability no violations, given you use your phone. These are usually not equal, so don't think they're automatically equal. Sometimes it happens and they are, just the luck of the numbers, but usually they are not. When you're given something, only use that row or column. So we know there's no violations. That means it's coming from this group then. So we narrowed it down to 685 people. And using a phone would be 280 out of the 685. So whatever is given, narrow it to that row or column only. So since it said no violations, we're only using this one. Using a phone then would be 280 out of the 685. There is a formula. There's one problem on the take home you'll have to use it for. So you could use the formula. If we did. Probability of A and B we found over there was 280 out of 755. Divided by probability of no violations. get the same answer. I don't usually use this one when I have a contingency table because of the fraction within a fraction. But there's one on the take home, one of the first, like 1, 2, or 3, it's at the beginning. Where you'll need to use this formula. So the probability the person has no violations given they use a cell phone. So we know they're using a cell phone, only use the row that they use cell phones. Which means we're only using this row. Probability, no violations, given they use cell phones, did you get 280 out of 305? So it's 280 out of 305. Any questions on that? So there's one where you have to find the distribution. So draw or write the distribution table. And then is it a probability? You're getting 0, 5/7, and 9/7. You're just plugging the value into the formula. Oops, wait, 0 is not 0, sorry. I added the +2 on that, I forgot. So 2/7. So I plug in 0, 0 plus 2 is 2/7. Plugging in 3, 3 plus 2 is 5/7. Plugging in 7 plus 2 is 9/7. To be a probability distribution, what are the two main things that it has to have? It needs to add to 1, and the individual values have to be between 0 and 1. Nine sevenths is greater than 1. So one of the probabilities is larger than 1. And when you add them, they don't add to 1. So they have to add to 1, and none of the values can be larger than 1. They have to be positive, which they are. So f of x has to be between 0 and 1. All these answers have to be between 0 and 1, and then they have to add up to 1. So if you remember, that means to add all of the f of x values, they need to equal 1 to be a probability distribution. Those are the two main things you need to check, and you need to tell me which one or both they fail. Using the same one. Just so you can see, well, also I want to find something with it. So there's one question that asks you about the probability. There's another one where it's already written, but we'll just use this example. And you have to find mean, variance, and standard deviation. So if we plug this one in, we have, what were 2 sevenths, 3 sevenths, and 4. No, that doesn't add up. Make this a 9, so it'll work. There we go. So if we have this probability distribution, notice all of these are between 0 and 1. And if you add them up, they add up to 1. So this would be a probability distribution. But there's one on the test, the end class, where it will already be drawn out, and you'll have to find the mean, variance, and the standard deviation. Does anyone remember how to find the mean? Just like expected value, you take each x times f of x and add them. So x times f of x. Each x times its probability and add them up. This one is similar to number 7 on the take home. 11 nights. If you were rounding, this is a mean, you go one decimal place further than the data. The data is whole number, so it would be 1.2. If it doesn't specify fraction or decimal, it would be up to you. On the take. This one, we take each X value, square it, and then multiply it by its probability, and then subtract the value we just found squared. Going one decimal place further than my data, 0.6. Now, notice when I found this, I used the unrounded version. Same thing here, when I take the square root, I'm not gonna use 0.6. I'm gonna use the whole decimal in my calculator. Now, according to Alex, as long as you go 4 decimal places, it should be fine, but I would just use the whole thing in your calculator and just take the square root of it. Again, rounding one decimal place. So this one's on the take home. I thought I had one on the in-class, but I don't think I do because it's on here. I didn't bring it with me. That part is on the in-person, this is on the take. Any questions on it? There's one problem on the take. I put 2 here so we can practice, but find the z-score for each shaded region. These curves should never touch the horizontal line. They just get close to it. I'll bring the table up. Sense. So you will be given a Z table. You will not need the binomial table on the test. On the in-person test. You'll just have to, that one problem with the formula. But it is on the take home. So to open those, you can go to the book. And then here's the binomial table and here's the standard normal. And you'll have a one page. That's all you'll need. So the first one, 0.4227. You want to find the Z value. When you're given the part under the curve, you're going to look inside the table and work out. Now the table, notice it's giving you the area below, which is what we have. So we want to look for the 0.4227. Another thing you can tell, because of the way it's shaded, it's over here. It's going to be negative. If it was over here on the right of the zero, it would be positive. So if you're getting the wrong answer or not getting a negative in this case, you're doing something wrong. So we know it's supposed to be negative. So we'll go here. Looking for 0.4227. Probability under the curve is in here somewhere, not out here. These are the Z values. We want, here's 0.42, we want 227. 4. Okay, so it's in between this one and this one. When it's in between, you need to decide which one is it closer to. It's right in the middle, huh? 21 like 20 another. So you take the larger. So if it's right in the middle, you take the larger. If it's not, you take whichever it's closest to. Well, 4227 is right in the middle of this one and this one. So we take the larger, go across, negative 0.1. Now I need to find the spot. I know it's a 9. Notice it's on the end. If I go up, this is 0.09. So this is your first digit after the decimal. This is the second. And since we're here, it's a 9. If we were in this column, it would be a 6. So it's negative 0.19. Now there's one or the other. I just figured we're better having an example of both. Any questions on that one? Now this one is shading above. Can we look up 0.09 in our table? I mean, we can look it up, but would it give us the ratings? It's going to give us the Z over here. It'll give you the right value. It'll just be the wrong sign. We need to know what's in this area. Because remember the curve I showed you, it showed you to the left. So we need to find this. How do we find this area? They're complements. This is one part, this is the other part, they need to add to one. So 1 minus 0.09 is 0.91. So this area is 0.91. Then it's just like we did here. But you have to have the probability to the left for this table. Now, some tables are different, so once we get into later ones, you always want to look here and see if it's below. Like if we look at the t distribution, it's above. Well, it also has two tail, which we'll learn more about, but. So we're looking for point. Okay. 0.9. So here's a 0.9. It's 0.9. Right here. Is it closer to the number on the right or the left? Left? Oh. Because it would be, you could just subtract it from it and you'll see that it's closer to this one. So it's 1.3, and then this starts with 0. 0, 1, 2, 3, 4. So it's 1.34. I'm trying to subtract it. Yeah. Right? Subtract it right in the head. 0.91. What you might be getting is 1, and then you get an e to the -4. It's just giving you scientific notation. Which means move over 1. So on your calculator, you get, it doesn't mean it's an error, it's just scientific notation because the number was so small. If this one gave you scientific notation, it'd be 1.5, and then it'd have an e -3. Any questions on that? So there's one where I just shaved the curve and asked you to find z. If my phone goes off, well, I know it's gonna go off at 1:30. I have to wake my husband up. He got home at probably 9 and he's gotta be at work at 3. Okay, number 7, a sloth moves at an average speed of 6 feet per minute. with a standard deviation of 2 feet per minute. And is normally distributed. Okay, the 60th percentile. What does 60th percentile mean? If you're in the 60th percentile. %60 are below you. So if you're looking for the 60th percentile or the speed of the sloth with the 60th percentile. We know halfway is 50%. So you know your Z is going to be over here. We know that this is 60th percentile. This one's there is one part on this that's on the in class. But most of it's on the table. Okay, so first we need to find our Z value. Formulas for normal distribution. Z value is X minus the mean divided by the standard deviation. If it's a sample, now for this one, once we find the Z value, we're going to need to find X because we want to know what value 60% of the slots are below, what speed. So this is the formulas. There's also the sample part. You want to put it all together. The mean of a sample is equal to the mean. The standard deviation of a sample is the standard deviation divided by the square root of that. So if we look for 0.6 in our table. It's right in between here. Okay, so it's 0.0013 away from this one. It's 0.0026 from this one, so it's closer to this one. So it's 0.2. And then to find the next decimal, remember this starts with 0. 0, 1, 2, 3, 4, 5. Any questions on how I'm getting the 5? If I stay in this column and go up. There's the 5. 0, 1, 2, 3, 4, 5. Any questions on that? So that gets you the Z value, but to find the speed of the sloth, this is our mean. This is our standard deviation. We plug it into this value to find X. So if you're looking for a Z value and you have an X, you use this one. If you have Z and you're looking for X, you use this. As long as you turn the Friday's assignment in, I didn't grade it. I just give you the points. As long as it was turned in on time. So Z. Getting 3.5. That doesn't make sense. Oh. Be careful. I do this every time. Sorry. Be careful. Make sure your standard deviation is here and your mean is here. Okay, so find the probability the sloth moves slower than 5 feet per second. I think it was a minute. Find your Z value. Give me a take. Good morning. You up? All right, I'm in the middle of class, but I wanted to make sure you woke up. Was it 2 or 3? 2. To get a negative 0.5 for the Z value. Okay, so if we draw our curve. Well, this time we're given the Z value. We want to find the area under the curve, and we said slower than, so that would be here. Oh, is that your neck? So we want to look up negative 0.5, which and negative 0.50, so it would be the very first column. That's the area under the curve. 0.308. So the probability that, they move slower than 5 feet is 0.3085, 31%. So it would be the 31st percentile. When you're looking the data up on the curve, it gives you the percent below. And that's what we were looking for, so we didn't have to go further. What is the probability they move faster than 9 feet per minute? Getting 1.5 for your Z value. So when we mark it, 1.5 would be here because it's positive, it's above the middle. Now, do we want to shade below or above? Because we want it to move faster than the 1.5, we want to shade above. One point five is here because the second decimal place is a 0. Point 9332. Is that the answer that we want? No. Because that's the unshaded region, right? How do we find the shaded region? Subtract it from 1. So almost 7% of slots move faster than 6 feet per minute. Any questions on that? I stopped 4 minutes. This one is on the in class part. Most of those other ones are not. Just time reasoning. But to need normally distributed, what do you have to have? Let me see, how could I? Your sample size has to be what, or it needs to be normally distributed? So this one, the statement needs to say normally distributed because our sample size is less than 30. If the sample size is greater than 30, then normally distributed is not needed. Because our sample size is less than 30, we need it to be normally distributed. If it was greater than 30, then you would say you didn't need it. Then you also need to find the mean, standard deviation, and a z-value. Remember, I gave you the formulas. The mean is the same as the mean from the sample, which was 6. The standard deviation is the standard deviation from the original problem divided by the square root of n. And I think it was 2. 2 divided by the square root of 10. Standard deviations, 1 decimal place further than your data, so 0.6. Using the sampling of 10, find the z-score. A lot of students were texting me last night, well, not a lot, because there's only 20 in here, but more than one, a couple, which is fine, but be careful. Your x value minus your mean divided by. Now, if you're putting it all at once, you need to put this in parentheses, and that's why there were so many weird values. Should be getting a negative 3.16. Z values go 2 decimal places. Question.
Thank you.
Any questions?
Okay.
I will see you tomorrow.